Hello and welcome. We're going to be talking about the features of parabolas and also be working with quadratic functions on this lesson. Let me go ahead and get you started with how to interpret the graph. So everything I need to know to answer these kinds of questions from a graph can come from these 4 points right here, the intercepts, and the maximum or minimum. And so I'm going to just label that these points are negative 5, 0, negative 3, 4, negative 1, 0, and this one down here is 0, negative 5. Now I'm going to be able to answer what are the coordinates of the zeros. Well, I would say that there's 2 points that are zeros. Zeros are always other words for x-intercepts. So where do you get an output of 0? So negative 5, 0, negative 1, 0. Those are the zeros. Now the x-intercepts are exactly what I just listed. It's actually just another way of asking the same thing. So I'd say there's 2 points that are x-intercepts, negative 5, 0, and negative 1, 0. So wherever it's hitting the x-axis. Doesn't matter how they're asking that question, the answer is the same. All right, coordinates of the y-intercept. So instead, where does it hit the y-axis at? There's only 1 point where it does, at 0, negative 5. Right here. Determine the coordinates of the vertex. There's 1 vertex. There always will only be 1 vertex on these problems. You'll see relatives in the future, but for right now there's only 1, and it's at negative 3, 4. This vertex would be called a maximum due to the graph going down from there. Finally, what's the equation of the axis of symmetry? It is always the x value of the vertex. So you would answer this with x equals negative 3. So look at your vertex. It's always the x value. By the way, just a quick side note, that would actually be representing this vertical line that the graph reflects over. All right, that completes our information we would need to be able to get from the graph. Next up, we have calculating our axis of symmetry from a function. What you would need to know for that is that it is in standard form, meaning y equals ax squared plus bx plus c. And so here a is negative 1, b is negative 4, c is negative 8, as far as what numbers those values are. Next, you would need to know what the axis of symmetry formula is. It is negative b divided by 2a. So now I'll start substituting values for b and a. So b is negative 4, so it'll go negative 4 divided by 2 times a, which will be 2 times negative 1. So that's going to be positive 4 on the top because a negative times a negative is a positive. And 2 times negative 1 is negative 2 on the denominator. I should use those terms, numerator, denominator. And now I'll just divide 4 divided by negative 2 is negative 2 is my answer for my axis of symmetry. Again, this will be the line that the graph's reflecting over onto itself. The only thing I want to add here is if ever you had, I'm going to kind of show you a separate kind of example to the side here that wasn't part of this problem was finished. Like if you had y equals x squared plus 6, the value for a would be 1 and the value for b would be 0. The result of such a problem would be that you would have 0 divided by 2, which would just be 0. So I did want to point out that it is possible for you to have an axis symmetry of 0 if there is no x term. All right, that wraps that one. So now we're going to take a look at a problem where we're going to find the vertex. Now really the first part of the problem is actually the same as what y'all just saw me do, because to find the x value, we're going to get that from the axis of symmetry. So a is 4, b is 56, c is 188, and what I can do is go ahead and do x equals negative b divided by 2a and get negative 56 divided by 2 times 4, which would be negative 56 divided by 8. All right, and just a quick calculation. You can use a calculator there. That's going to equal -7. Now what I do is I actually plug that into the function in order to get the y value of the vertex. So it's going to be y equals 4x squared, but notice how I'm putting -7 in for x right there, plus 56x, which I'm putting in -7, plus 188. Now you can do this by hand. Most of you would probably opt for using a calculator to calculate it, but I'll do pieces of it by hand right here. So you could just type all this into your scientific calculator or graphing calculator, but I'll just do it by hand to show you that it's possible. All right, -7 squared would be -7 times -7, which would be 49. While I'm at it, I could do 56 times -7, which ends up being -392. I can now do 4 times 49, which is going to be 196, minus 392, plus 188. And yeah, I'm just doing that on a calculator off to the side. I don't really feel like doing all that by hand. This is calculator active in this class after all. So y equals -8. All right, after all that work, we do have our answer, -7, -8. What you're going to see on the next problems, though, is that there's a way to do this without using the algebraic process. We could just use technology, which is what we're going to do next. All right, so on the next group of problems, it actually says on a calculator in the instructions, we're going to find the roots and the vertex. Roots is something I've shown to do with quadratic formula. Vertex is something I'm going to show now. So I'm just going to go ahead and be like, hey, you can actually do this by hand or you can use a calculator. So I'm going to go and type in the function y equals x squared plus 6x minus 112. And I'm going to zoom out a bit to get my image on the graph. Now the roots are the -14 and +8 where it hits the x-axis. So if you're doing this delta math assignment, that's all you would type in for your roots. Now be sure that you're clicking on the minimum point. There is a y-intercept that's pretty close here to it. But be sure you're clicking on the minimum point here. The minimum is -3, -121. So I can go ahead and answer the vertex problem right there. And I've done it with a calculator instead. Completely doable by hand. It's the same work, but it was a bit quicker with the calculator, so that's definitely open to you. All right, I'm going to do one more like that. So this one's going to be very similar. The difference is going to come that I'm going to have to actually round. So y equals 3x squared plus 9x minus 293. This ends up being irrational, so I'm going to zoom it out to get everything on the window here. There we go. So you can see just how similar this went at the beginning. I just tap on the roots and I tap on the vertex. Okay, so now as far as my roots go, I'm actually going to answer with -11.496. I'm going to have that 8 round that up to a 6. Now why did I go that far? In the instructions it said round all values to 3 decimal places if necessary. It's definitely necessary on this problem. So one of my roots is -11.496. And then the other one is 8.496. I'm going to have to round up there as well, 8.496. Didn't have enough room in the boxes, so I just kind of wrote it up above them. Anyways, those are the roots. Wrapping up here, I'm going to go ahead and write in my vertex. Now here I don't have to round. These are actually rational values. So -1.5. I'm just going to write it below it since I don't have enough room in the boxes. And -299.75. You shouldn't have to be rounding on any of your vertexes. Vertices. Yeah, okay. Anyways, if you have questions, please email me or let me know. Just ask in class because this won't be late until after I return from being absent. All right, thank you very much, guys. Good luck.